right, good afternoon, everyone. All right, at least two people. So my name is Rajiv Chaudhary. I'm part of IBM software business based in New York. I'm accompanied by my colleague Guy Taglavia. I'm responsible for the IBM global financial markets business in software, and joined IBM about 3 years back from Goldman Sachs, where I used to do trading activities around the world, and jumped into IT side of the business about 3 years back. So looking forward to spending next 15-30 minutes with you talking about some of the global challenges, and I'm going to really go in more simplified way. I think you had a great sessions today talking about the high frequency trading. You had discussions around risk management, OMS, EMS, DMA. All of those are a driving force behind the electronification of the markets globally. And it has a long-term impact in terms of not just from a technology innovation standpoint, but also from a human capital perspective. With all the changes in the technology, human behavior has to change as well. And it also changing how human brain starts to functions, not looking from a siloed technology standpoint, but also looking at from a cross-asset, cross-shared services standpoint. So we're going to quickly talk about some of the key challenges and the complexity we face in the global markets. And then my colleague Guy is going to talk through some of the advances and the innovations which we all have to think about as you build out your business or expand your business in the global markets. So in lights of the financial markets, I mean, I think Andres' slides covered it pretty well in terms of the timelines of what has happened from 2008 to 2010. I mean, we have seen this market has become complex. We're trying to get more transparent. But in light of all this, we see the continuous expansion of electronic trading. The wave we had in North American markets about 10 years back, and the way we are seeing how the Latin America and the Asian markets picking up that speed and the steam, it's just mind-boggling. The growth aspect is phenomenal in terms of the amount of time it took the buy side and the sell side, as well as exchanges, to transition them to more into the electronic side of the business, took about 5-7 years. And if you start to look at what's happening in Brazil and in China and other countries, India as well, there is a tremendous jump here in terms of not have to deal with the legacy, but at the same time kind of going right into the heart of the driving the core business. So I think we're going to continue to see this expansion of electronic trading. We have evolution going on right now into cross-asset side of the business. People are doing that aggressively. We are seeing the algorithmic trading rapidly expanding into additional asset classes. We talked a lot about the equity side of the business throughout the day, but we're seeing the similar high frequency and the algorithmic development happening on the foreign exchange side as well as on the fixed income side of the business. So I think there is we will still have more to come to and more to look forward to as new products and assets will get created, leveraging the technology as well as the human capital. The next one, I think we talked a lot about this, regulatory compliance. The transparency is going to be absolutely key. Whether Dodd-Frank Walker rule has 400 unanswered questions, or out of 76 rules, 21 rules are written, There is a lot of unknowns, but I think the regulators, they are still struggling, but they are working together to how to manage the systemic risk. And we will see the local country regulations going to step up and continue to drive what is important to have the integrity and stability in our financial systems, because we have had a very tough times in the 2008. We're still trying to recover from it, but I think it's going to be absolutely key for the regulators, the entire financial markets ecosystem to come together and ensure that there is a transparency required, and people like us have to step up to the plate to ensure that we support those regulations, as well as support the transparency what is required, because it's in our best interest. And the last piece, I think, which is not been touched at all in this conference as of now, or until now, is especially from the asset management side and from the wealth management side. The clients are the most important assets we have. And how do you attract? We all talked about attracting liquidity, but how do you attract and retain the clients is important. And in the exchange and the broker-dealer world, I think the transaction cost analysis is important. I think Marcio talked about that in his panel a bit. But again, just step back and look at the asset management and the wealth management and the high net worth business. Given what's happening around us in the global economy, the low income earners are beginning to rise. The middle class is gaining more strength, and all of that wage they have earned is coming back into the economy. And as my last check of about a couple months back, there is about $4.8 trillion sitting in money market accounts earning 0.5% interest. So all of that is ready to come into the market as the uncertainty goes away, as people are feeling more comfortable to invest into the liquid markets. And I think we're going to start to see an uptick of that cash flow coming into the business. So I think which is all good news for all of us. But my point here is that focus on the clients. I mean, some of you are from the buy side, and that's where how you take the advantage of the analytics side of the business and really providing to your relationship managers the 360 view of your consumer or your client base to ensure that you provide either trading products, asset management products, retirement products. I think all of that is going to be becoming critical to our financial markets business. I'm sure you probably have seen some of these slides in the past, but the most telling point in here is that the data growth, and apologies for putting the North American side of the house, but you see the similar curve happening in the Asian markets as well as in the Latin American markets as well. So the point here is that the trend of the growth in volume is going to continue. It's not going to go down, it's going to continue. And technology will play a key part in terms of how you efficiently manage it, how you efficiently keep your costs down of managing this infrastructure and continue to provide new products and better services to your clients. The right-hand side of the picture, I'm not sure you can see it clearly here, but I'll just point it out to you. We all talked about low latency, high frequency, algorithms, all that. When the ITA group did their recent study, risk management is on the top of everybody's list. That's where the money is getting spent in North America and the European markets. It may be a little bit slightly different in the Latin America as well as Asia. But the risk management, the EMS side of the business, and as well as the analytics are on the top of the agenda for the Chief Information Officer as well as Chief Executive Officer and Chief Risk Officer. So those are the where the dollars are being spent, and we're going to continue to see technology being leveraged in those areas to reduce the cost of ownership. Again, probably you have seen all these slides before, but the 2 points from this is the algorithmic trading is definitely continue to grow. I think one of the panel before says 60 to 70% in trading in North America is happening using algorithms, and it's gonna probably continue from that. Australia, for example. They were about, in 2008, they were about 7% of the trading was program trading base. And as of now, it's about 26%. So you're seeing a tremendous growth. China, the recent report, I don't know if you have seen, today it's about 0.6% of the trading is algorithmic based. By 2013, they're talking about at least 4 to 5%. And the volumes are huge in China, and when you compute that to 4%, it's a tremendous amount of growth they are facing. And again, the regulatory changes is gonna bring a lot more in terms of once they start doing Shanghai, Shenzhen, as well as and Hong Kong cross trading there. And then the last part is to my earlier point is the equity has the lead on it, foreign exchange. Fixed income, foreign exchange, foreign exchange, fixed income, and options market are definitely picking up pace in this area as well. So we all have to look out for those things. I'm going a little bit more in detail. You know, when we go and talk to the clients, you either talk to the market data person, you talk to your electronic execution side, you may talk to your people who are writing the algos. But in order to really win in this space, you have to look at it end to end. You have to ensure that you have a complete focus, including your hardware, your network, your market data, your messaging system. If you're using event processing engines, you are using your order routing systems, you are using the exchange. Exchanges also plays a key role in here. So it's really a complete latency loop, as I call it, and you have to ensure that every path you have an optimal. And I think one of the Sebastian in the morning kind of pointed out that the detail matters. And detail matters in each and every functions, which starts from accessing the liquidity down to executing an order, as well as going back into how you efficiently support the operations from a back office standpoint for clearing and settlement. So the point here of this slide is really about you focus on each and every aspect of your business functions and try to figure out where optimally you can focus on reducing the latency. And then everybody can do this. Everybody who has money can buy the latest and the greatest hardware, software, technology, human beings, all of that stuff. And it all comes down to is that the key differentiator in all this will be your execution algorithms. Right? That's the asset you have to invest the most in to ensure that you have and you provide that to attract the liquidity in the marketplace. And this is my last slide, and I'm going to hand to my colleague Guy here. It was interesting. You know, one of the questions I got asked by a client is that what is the how the customer has evolved from 1970s. And you know, in 1970s, people were making loads of money, in 80s and 90s and everything. So I think from period of 70 to 90s, I think we all looked at, I'm an equity trader, and I'm feeling very comfortable. I'm making money on every trade I do, and I'm going to spend the money on what is important to me, right? So it was all about siloed focus, right? And still it's there, it's out there in the marketplace, but the siloed focus is no longer cost effective for the organization as a whole. So you have to ensure that, so again, the point here is that it moved from a product-based approach to a cross-asset, which is the current thinking what customers are going through. And also in the future, we're going to have a much more highly complex environment when all this unstructured data, Andres in the morning pointed out all this big data stuff coming, right? Big data has been around for a long time. I mean, everybody has lots of data. Now it's just that amount, what you do with that data and how you gain insight from the data is important. And it all comes down to its analytics. So we're going to see a much more complex organization. And all of these things we talked about throughout the day is like pouring an oil in the fire, right? I mean, and that's what it's all about. So with that, I'm going to have Guy kind of talk about some of the technology evolution and the innovation, what is happening in the marketplace, things what you can take away from this conference. Guy?
Thank you, Rajiv. All right, well, the great thing about IBM is that we have great business minds like Rajiv, and then you've got guys like me. But in any event, I'm Guy Tagleby. I've been in this industry a long time, and I've been mainly on the technology side of the business. And I currently, within IBM, run the front office business for IBM. And I came into IBM through an acquisition of my business. So I was also a business owner, but still always had my heart in technology. And the technology we brought into IBM and then the technology we leveraged while in IBM has come together in a nice way. And I'm not really here to talk about that, but I am going to talk about just very high-level concepts, things that everyone should sort of think about, and a little bit about some of the trends and the directions in this in the technology side of the industry, and how that benefits some of the things that Rajiv has already discussed today. So when we look at our systems, a conceptual view of these systems, these are systems that are deployed. There's many dispersed processes and activities going on. There's hardware, software, operating systems, networking, and all of this has to somehow come together. And many folks take a look at their applications and they view the infrastructure as a means for implementing their application. Well, I've always thought of the application as a means for implementing the infrastructure. And to do that, I've always looked across many different types of applications and how I'm going to want to modify my applications down the road, or how I'm going to want to modify my architecture down the road, and what kind of things I'm going to run into down the road as I start to want to scale the system, if I want to add more applications, if I need to tie in more data or distribute this data to more users. So this is all things that you need to think about over time. And of course, that all starts from sort of the bottom level all the way up. And you have to think about things like, how do I manage, how do I monitor, how do I upgrade, when do I upgrade? If I need to run a 24/7 operation, how do I do that? If it needs to be redundant, load balanced, all these things come into play. So how do we do that? Okay, so how do I do that? That sounds like a lot of work. It sounds very difficult to do that kind of thing. But actually, if you take a look at that problem and you take a look at some of the options you have for solving those problems, it should become very easy, actually. I've often heard people say, well, I implemented my solution quick and dirty just to get it up and running. Well, that was great, but if you had taken a little different approach and looked at it from an application perspective on down, you might have thought, well, if I use an underlying infrastructure and the proper infrastructure, I should be able to implement it quick and dirty and still achieve a better result. So in the 80s and 90s, there was this concept of an SOA architecture. And when people think of SOA, they always think about slow, monotonous, very rich, very functional, but slow. And if you could have the best of both worlds where you had an SOA architecture and yet it was very fast and based on the latest technology and messaging approaches, that would be the best of both worlds. So in this architecture, it'd be great if I can use it. I can scale the system. I could deploy it in a manner in which I can monitor it and support it, and I can evolve it over time as well as my business needs change. So what does this look like? What does this infrastructure look like? So again, from a bottom-up approach, I like to think about the fact that you have many different underlying messaging transports. Customers want to implement their messaging over different types of transports, let's say shared memory. If you're running two applications in the same box, it'd be great if they communicated right across a memory transport. On the other hand, if I want to split those across a network and I want to retain reliability, I might implement that over a TCP connection. Then again, if I have to distribute one-to-many or many-to-one, I want to do that over a multicast type environment. And then finally, if I want to make sure a message absolutely gets from point A to point B, I want to use some kind of guaranteed messaging capability. So ideally, I'd like to have all those capabilities underneath my application and be able to enable them or disable them as needed, or even deploy them in certain scenarios for certain use cases. Now, beyond that, I'd like to have a set of platform services, things that can provide me with resolution services. So when my application comes up and forms a session to the system, I don't want to have to know or care where it connects. I don't want to have to know or care where to go get the data. I just want to get my data and go, or I want to publish my data to users or requests and have it go. Load balancing and failover and recovery. When I deploy my service in a system, I want to make sure that I can deploy it twice or 3 times or 4 times and have n levels of redundancy. I want to know that if something fails, it will keep going, or the service will still be available in the system even though one of the instances has failed. I might want to extend these applications over multiple LANs or WANs, or even over the internet or an extranet. I want to have some of my systems hosted in one facility and users running somewhere else. So how do I accomplish all that? And then finally, I want to do things like controlling the system. I want to be able to have certain applications have certain privileges, or might want to have certain users have certain access to certain kinds of data. So these things all become important. And then finally, I might want to have some services available to my application. So when I'm creating data or subscribing to data, how should that data look? Where does it get cached? How do I modify it? How do I publish it? How do I subscribe to it? So these are all things I want the underlying APIs and toolkits to take care of for me. So again, by doing that, by focusing on that lower level infrastructure, I can now start to just think about my applications. I can think about the applications that are going to solve my business problem and not worry about the underlying infrastructure. And if I am worrying about the underlying infrastructure, I'm probably going to do it in a very specific way. I'll certainly get it done. But then when my business changes or my model changes or I need to grow, I'm suddenly going back and revisiting my infrastructure, and it becomes a major change. So I mentioned earlier, wouldn't it be great to have the best of both worlds when you look at this type of infrastructure, as well as the performance characteristics we're talking about. And there's been a number of interesting trends, and I'll talk about one in just a moment, but if you look at just the CPU power that is out there today, we've made great strides in parallelizing processors and adding cores and having multi-CPU systems, and as well the threading models and all that go into our operating systems and our applications. However, we are running up against a breaking point, and we're starting to look at some other capabilities out there as we look at things like field programmable arrays. Now, a field programmable array, for those of you that are not aware of those, I know they were mentioned earlier today, they're basically an integrated circuit that becomes a workload or becomes a program in the field. Now, that's very interesting because normally the way we got there was through ASIC. An ASIC is a chip that gets manufactured with a certain logic or workload, and it's produced and it's mass produced thereafter. And it's a very expensive way because these things have to be designed, they have to be manufactured, fabricated. You have to order about 1 million or 1 billion of them in order to be cost effective. So the real goal here is I want to be able to do this, but I want it to be very flexible. And the FPGAs have been around for a long time, but at the same time they haven't been very usable because the densities that are capable within these devices haven't been as high. But lately that's been changing pretty dramatically. So the logic elements you'll see here are going up pretty significantly, and we're starting to get from 180 nanometer now down to 28 nanometer on these chips. And the power consumption further is very much reduced. We're talking about a chip and a card that might draw 30 watts as opposed to a 180 watt or a 200 watt CPU. So that keeps the heat down, and yet we have the number of logic elements we need to actually put more sophisticated workloads onto these devices. So a lot of people talk about Murphy's Law, but I'm going to talk here a little bit about Amdau's Law. And Amdau's Law really talks about the fact that spreading the compute activities of an application across more CPUs is great. You can do a lot of paralleling, but at the end of the day, the application or some segment of that application is only going to go as fast as as one processor or one thread will allow it. So what this is finally saying, if you take away all the equations, is that what you really need is vertical acceleration rather than horizontal acceleration. And we're starting to find that, especially in financial markets. When you look at these data feeds and the amount of data flowing from the exchanges and the amount of data that has to be processed, it's pretty significant. And trying to process that in a parallel environment can be accomplished by spreading it out, but then at some point it all does have to funnel up into some application or some part of an application that has to do some filtering. Wouldn't it be great if you can do that at the speed of a gate down on a chip and alleviate that need from the application of the CPU itself? So I've heard a lot of debates about CPUs versus FPGAs or other hardware acceleration devices, and I believe that there's a place for both. It's not an either-or campaign. We don't have to have a debate about whether it's easier or harder to program an FPGA. I would say it's actually harder right now. We're trying to fix that, but or whether CPUs are too slow or too expensive. But at the end of the day, I think they both have a place. And the real trick here is to find a way to leverage both. And I think you're going to see that as time goes on, we'll see attach points between FPGAs and CPUs that will start to increase the capabilities of our computing systems as a whole. You'll start to see PCI attach, and then memory attach, and then finally wafer attach. So you're 3D stacking FPGAs right on a wafer. And that's some pretty exciting technology. So what that will allow us to do now is to take a portion of the application that does things like I/O and ingress-egress logic, encoding, decoding, or even customers' custom logic, and put it down on the FPGA where the data is flowing in and out of the application, and do it at line speed with very extremely low latency. Meanwhile, the application proper can still run in the CPU world and still perform the bulk of its activities as needed. So what you're starting to see, not just from vendors such as IBM, but many vendors are in this space, starting to develop solutions where you take an FPGA card with intelligence on it that process network data I/O that are then plugged into a computer, a standard computer, and the trick really is to package this in a way that it's transparent to your application. In other words, your application shouldn't care or know that it's even there. And again, that goes back to the architecture I talked about earlier in the infrastructure. So if you start to accelerate those lower levels of the stack, your application actually is programmed up at that higher level API. And when this technology becomes available, your application shouldn't care, it just gets sped up. Of course, when you think about doing this, you don't want to think about just doing it just to solve one problem. You want to solve a broad number of problems. So you really need a whole environment around it to program these devices. So when we want to program these devices, we don't want to have to write in VHDL or Verilog. I don't know how many programmers are in the audience that know those things. I know I don't. So you really like to program these things using C2Gate technology. There's a standard evolving now called OpenCL. And then there's a research initiative within IBM that we've been working on called Lime, which is actually a Java version. And what that does is that takes the higher level languages and synthesizes them down into the workloads that'll run on the chip. So you're going to start to see some of the tooling become available that will allow easier ways to program these devices. I think the good news is, even though with all of the need for low latency, all of the higher message rates we've been talking about, the good news is I think technology is responding, and I think you're going to see some of these solutions solving a lot of these problems as we go forward. So thank you very much. We really enjoyed coming here, and thank you to the Exchange and Andreas for hosting. And if there's any questions now for Rajiv or I, we'd be happy to answer.